Good day, students. In this group, we're going to be going over two examples on how to find the domain of composite functions. Let's go ahead and get started. Before we take a look at some examples, we're going to go over the depth of what it means to find the domain of composite function. Okay. All right. So the domain of composite functions. The domain of f composed with g of x includes all the elements x in the domain of g of x, for which g of x is in the domain of f of x. Okay. So what is the procedure for finding the domain of f composed with g of x? So this is the algorithm or steps for finding the domain. Okay. So starting from number one, first thing you want to do is find the domain of f of x. And then after you do that, whatever result you get for your domain restriction on x, you are going to replace g of x with that x, which is the restriction on the domain of f of x, and then you solve for x, okay? And that will be part of your domain of f composed with g of x. And then the second part is you find the domain of g of x, and then after you find the domain of g of x, you exclude the restrictions from the domain of g of x that you got in step 3. You just include that to the domain or the restriction you got in step 2 by substituting the restriction in the domain of f of x into g of x. Okay? So in order for all these steps to make sense, we're going to look at it within the context of an example. So let's consider the first example. Question 1. State the domain of f composed with g for f equals 1 over x minus 1 and g of x equals x squared. So we can find the domain without even composing the two functions. That's what the algorithm is for. So for your reference, I'm going to have the algorithm projected here on the side, and then we're going to use it. Alright, so let's go ahead and apply to this problem. So step 1 is we're going to find the domain of f of x. F is a parent function. So since this is a rational function, for rational functions, the denominator cannot be 0. So what I do is I extract the denominator x minus 1 and require for it not to be equal to 0. Isolate x by adding 1 to both sides. So this is the domain of f of x. Okay. Now I'm going to move on to step 2, which is a little bit technical. What I'm going to do is I'm going to take this and I'm going to replace this x with the function g of x. Alright? So g of x is x squared. You see that x squared right here? The whole function g of x replaces the restriction on x in the domain of f. Alright? So if I make a substitution here, I'm going to have x squared cannot be equal to 1. Okay, so the procedure again is you take g of x, where we have the restriction on x from f of x, you substitute that value, that function, into the x, and you have this, okay? So if I solve this, that will complete my first part of the domain. So to solve this, I'll just take the square root of both sides. So you take the square root of a square. On the left side, you end up with absolute value of x cannot be equal to 1, because the square root of 1 is just 1, okay? Now, solving an absolute value inequality of this nature, we'll replace the absolute value bars with plus or minus 1. And then divide both sides by plus or minus 1. That yields x cannot be plus or minus 1. Okay, so we're done with step 2. Alright, next we're going to look at step number 3. So in step 3, we're going to shift our attention to the inner function, which is g, and then we're going to ask ourselves what is the restriction on g. So now let's shift our attention to g of x. The domain of g of x is all real numbers. It doesn't have an radical or a rational determinant. So there are no restrictions on x squared. X squared can take in any x value and guaranteed to have an output, a real output. So the domain of f of g of x is all real numbers. So there are no restrictions here. So this initial domain we have will suffice as the domain of the composite function. So domain of f of g of x, which is what the original question asked us to find, is simply x cannot be plus or minus 1 because there are no restrictions from step 3 to exclude from this original result, okay, or to include or exclude. All right, so the domain is x cannot be plus or minus 1. All right, let's go ahead and try another example. Question 2, state the domain of the function f composite g of x for f of x equals the square root of x minus 1 and g of x equals 1 over the quantity x squared minus 8. Okay, so I'm going to provide the steps on the right side for your reference again. So let's start with step 1. Step 1 is we're going to look for the domain of f. Okay, so to find that, what we'll do, the domain of f, we know that we have a radical function, so the radicand has to be greater than or equal to 0. If it's negative, we'll have imaginary results. So what we'll do is we take the radicand x squared minus 1, require it to be greater than or equal to 0. Now what we're going to do is we're going to solve for x. So to solve for x, we'll add 1 to both sides, so you have x is greater than or equal to 1. Alright, now we're done with step 2. Now we're going to move on to step 3, which is to find the domain of no, actually, we're just done with step 1. We're going to move on to step 2. We're going to plug in g of x into this. So g of x is 1 divided by x squared minus 8. So this entire term will be substituted into the x that we got from the domain of f. So this entire expression of g will be substituted there. If we solve for x, that will be the first part of our domain. Okay, so let's go ahead and make the substitution. There you have it. I replace this x with g of x, which is 1 over x squared minus 8. So to solve this rational inequality, we're going to express 1 on the right as a fraction. We have a fraction on the left and a fraction on the right. Now we're going to cross multiply. For cross multiply, we're going to have 1 is greater than or equal to x squared minus 8. So the goal here again, remember, is to solve for x after making the replacement. X has not been isolated here. To isolate x, we're just going to do 2 more steps, which involves getting rid of negative 8 and then the 2. Okay? Alright, so how do we do that? We first of all add 8 to both sides. Or let's switch the inequality around. If we just switch the inequality around, we have x squared minus 8 is less than or equal to 1 is equivalent to this. I just switched both sides. And now, what we're going to do is we're going to cross multiply. Okay? Well, already cross multiply. So to get x squared by itself, I'll add 8 to both sides. And you have x squared as less than or equal to 9. And then to isolate x, you take the square root of both sides. And then you have the absolute value of x is less than or equal to 3. Okay? And then think back to how we solve absolute value inequalities. This is a bounded region, including the boundaries. This can be rewritten as negative 3 less than or equal to x, and x is less than or equal to 3. Okay? Alright, now we're done with step 2. Now let's move on to step 3. We're now going to find the domain of g of x. So to do that, to find the domain of g of x, we know that this is a rational expression, so the denominator can never be 0, cannot be 0. Any values that cause the denominator to be 0 has to be excluded from the domain, okay? So we're going to take the denominator x squared minus 8 and require it not to be 0. In this inequality right here, our goal is to isolate x so that we can know what the domain is, alright? So to isolate x, we'll add 8 to both sides and then take the square root. So we'll add 8 to both sides, we'll have x squared cannot be 8. And what we'll do next is we're going to take the square root of both sides to isolate x. Square root of a square is absolute value of x equals 2 root 2. If you break down 8 using the factor tree, you get 2 root 2. Now the absolute value is plus or minus. And then if we can write this as x cannot be plus or minus 2 root 2. Okay? So this is the domain on g of x. This is a restriction on g of x. If x were this value, then you're going to have 8 here, and then you have 8 minus 8, which will give you 0, alright, which is not acceptable. Now, what is the final domain? What is the final domain of f of g of x? The final domain of f of g of x involves combining these two domains or restrictions on x. So first part is x has to be between -3 and 3, and x cannot be plus or minus 2 root 2. Okay, so there goes your answer. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here. More videos can be found on modulstuff.com. Thanks again and have a wonderful day.